This is like an asymptote. Do you see how it just came down and it hugged the line and it never actually crossed it? Now, I drew in my own line. If I delete that and go with the picture, it flattens out. It'll never touch it. Okay, so this arrow will go forever. So therefore, does it ever cross the x-axis again? The answer is no. So there's only 1, 0, and that would be at the number 1, when x equals 1. Actually, zeros in the function, we probably want to write it as x equals 1 would be the zeros of the function. Questions on how I did that? Alright, so if there's no questions on that, then I'm going to have you guys try this equation here. So give the domain, the range, and the zeros of the function. Okay, so when you guys are doing those, remember, domain of the x's, does it go forever to the left and forever to the right? And on this problem, it does not go forever to the left. Okay, so that since it does not go forever to the left, where is the first starting point if you're coming from negative infinity and you're going along the x-axis? Where does it start at? And 1 would be the starting point. That's where that open dot is on the x-axis. Right above 1 on the x-axis would be the x starting point. Okay? And does it have a finishing point if you keep going along that roller coaster to the right? And even though there's no arrow there, I'm going to tell you it keeps going down and it keeps going to the right. So does it go to the right forever? Yep. So since it goes to the right forever, that means my domain is starting at 1 and going to the right. So on a number line, how would you start at 1 and go to the right? How do I name that with an inequality? So the domain is x, because we're talking about domain, is greater than, can it be equal to? No, because of the open dot. Okay, so it's just x is greater than 1. Alright, range are my y values. Okay, so does it go, again the question you ask is does it go forever up and forever down? If it goes forever in both directions, it's always all real numbers. Okay, but is there anything going on up in this section, this green section up there that I just circled in my graph? No, it stops on that barrier of 3, that blue dotted line. Does it go down forever? Yep. So if it starts at the highest peak of 3 and it goes down forever, how do we state that inequality? And what letter do I got to start with? So y is less than. Now on this one, I think because it's touching that blue line, yeah. So because it's touching that blue line, you see how it's touching right here? Since it's touching the blue line, we were going to say it is equal to, and then we got a 3. Questions on that? Zeros. What are the zeros of the function? Well, that's pretty simple. You guys know these ones already, I think. So the zeros of the function are x equals 2, 4, and 6. Okay? Alright, well, we are going to do the next slide here. And then I think after these next two, I think we are done for today. I don't know if I have anything else for you. So, function, so the definition of a function here is a function must have only one y value. So like, for instance, on this equation, one thing that can happen is these here would not make a function because the x squared and the y are multiplying together. Okay, and then here there's a y over here. Now you could move the y over, but here's the thing. This is one y value. This is a y value multiplied with an x squared. They're different y values. Okay, so then that's the one equation. And then here is the other equation. Now, this one you could probably graph in a calculator, but you'd have to actually do two separate functions. Okay? Actually, I think I might be lying to you here. Sorry, I didn't graph it. Let me back the train up here. This first one is a 1y value. It's not to the power of 2. Okay, so let me backtrack that last statement. When my y here is not to the power of 2, then we can probably have a function, because what I could do on this equation is move my y's over, factor out a y, and then get y by itself. On this one there's two y values, and I'll show you what they look like here on the next slide. Okay, so here, this is another way to determine if it's a function. If you don't like looking at the letters, which I think sometimes are tough, for sure, it's pretty easy if you graph it and you can visually see it. How do we test if a graph is a function? You take your vertical line test and you check, and as long as it crosses at one point on every single one, that means it is a function. So on this equation, the first one is a function. Okay, and does the second one cross multiple times? The second one does not cross multiple times, so therefore it is not a function, because it crossed once here and once there. So two crossings means it is not a function. So we will do this assignment here. So again, this week's kind of weird, so if you're watching another year other than this year, we are doing this section today, which is Monday, supposed to be Monday today. Tomorrow, Tuesday, we'll do a review assignment, which I'm going to review with you in class. And Wednesday is going to be our test for this chapter, chapter 3. So this is the start of chapter 4. I just threw it in so we could make it work out. And then on Thursday, you will actually be doing this assignment in class on Thursday. So good luck to you, and thank you for listening.